Okay, it looks like some folks are joining in, and I think we'll get started. Um, so thanks everyone for joining in on this workshop. This is the first of 3 workshops we'll be running this March, focused on a number of proving grounds tool offerings that we're putting out there into the wild as it relates to data management, workflow management, interoperability, and so on. This workshop is going to be focused on Conveyor. Conveyor is a Rhino to Revit workflow solution that is currently on version 2 of release. We published the new version of this tool in the last couple of weeks and have started to get people brought up into adopting some of the new enhanced capabilities of this workflow. My name is Nate Miller. I'm the founder and CEO of Proving Ground. And I'm joined by my colleague, Steve Sanda, who will be helping kind of moderate questions and do Q&A in the chat. So if you have questions as a participant, please feel free to use the question and answer interface. And if you have some general comments on the workshop, feel free to enter them into the chat. So, and it looks like we have our first question. Will this be published? And the answer to that is yes. This is going to be a recorded workshop. So you'll be able to refer back to it later on YouTube. I'm going to try to get it published up to YouTube either today or early tomorrow after the dust settles. So what I thought I would do is maybe just go through a couple of the general concepts I'll be covering in this workflow. This will be a live demonstration, and I will be doing some step-by-step operations with Conveyor using a couple of example models that we've curated. In the reminder email for this webinar, if you received it, there is a link to a data set that will be published after this workshop as well. So if you want to kind of scrub through some of the files that I'm showing, you're more than welcome to. So what I'm going to do is maybe just give a general overview as folks are joining in. Conveyor is a workflow set, workflow toolkit for Rhino to Revit interoperability. We're currently on version 2 of release. The first version of Conveyor was put out in March of 2020 and has grown its feature set rather significantly, I would say, in recent months. One set of workflows I'm going to be covering in this workshop relate to the idea of importing Rhino files into Revit using the Conveyor toolkit. And the basic workflow premise here is the idea that as a user, you are likely authoring Rhino geometry, Rhino data in the Rhino environment, developing designs. And at a certain point, you know that you're going to be migrating that information into Revit. And so what we're doing and exploiting with Conveyor is the availability of the Rhino 3DM file format, OpenNURBS, which itself is open source. One can write and create translators with OpenNURBS. And Conveyor is one such translator. So what it allows one to do is allow the user to develop Rhino geometry in that environment, in a standalone Rhino environment. And then using our translators and connectors, we're able to tell that geometry how it should become ingested into the Revit environment, which kind of provides this type of mirroring effect. We're able to see geometry transmit itself from point A to point B using this. And Rhino, in effect, is operating separately from Revit. It is not dependent on having Revit to execute this workflow, and it's not dependent on, if you're a Revit user, having necessarily Rhino for a portion of this workflow. So it can be pretty efficient in how you're kind of importing objects and things like that for certain functionality. A lot of teams that we see out there, have team members that might be responsible for Rhino models, team members that might be more responsible for the Revit and the BIM side. So this kind of allows for a bit of a bridging between those environments. The other side of this is thinking about how we are expanding the workflow paradigm. So the first version of Conveyor is very much about Rhino to Revit, supports Rhino, those workflows support Rhino 6 and Rhino 7 files. But there's also a number of toolkits that have been, and SDKs and API capabilities exposed with Rhino 7. Rhino 7 introduces what they refer to as the Rhino-Inside framework, which allows Rhino to act as a plugin into other applications, right? So you have this idea that you might be in Revit and you might want to launch Grasshopper, and you might want to then use Grasshopper and interact with the Rhino environment or the Revit environment through Grasshopper. And what this also allows us to do is it allows us to really build out toolkits that leverage that type of integration. So with Conveyor, we've devised a series of really simple interfaces that don't rely on Grasshopper. They don't rely on kind of more, interfaces that require sort of more advanced skill sets. The premise is that if you're in Revit, you can launch Rhino, you can click on an object and you can send it over into Revit. Or if you're in Revit, you can send an object over into Rhino. So you have this kind of more direct integration with hopefully for many a lower barrier to entry than what is provided sort of out of the box with Grasshopper. So that workflow looks something like this, where you're able to launch Rhino, click an object, classify it, and send it into the Revit environment and have that object load. So the workflow today, what I'm going to be doing with some live examples is I'm going to be touching on both. I'm going to be touching on this idea of being able to import objects into the Revit environment using the Conveyor tools. And then I'll also be talking about this and demonstrating this direct interaction on the same model. And I think the other kind of opportunity here is that those types of workflows, whether it's importing objects in or directly managing things through Revit, with the Rhino Inside capabilities, is that the workflows themselves can also be mixed and matched to accommodate a variety of different scenarios and workflow opportunities. I'm going to go ahead and get out of the PowerPoint, because that's the least fun part of this. I guess a quick overview of where you can get Conveyor. If you're following along, or if you're interested in knowing where to find these tools, and I'll return to this at the end of the workshop as well, is that we have a website, apps.provingground.io, where you're able to get access to Conveyor, learn more about it. There's a 15-day trial and also a commercial plugin. We have a lot of documentation, video tutorials and such. And then if you're using Rhino 7 and you're wanting to use Rhino, Conveyor with Rhino 7, there's also a free plugin SDK set that McNeil has published called Rhino.Inside.Revit that we are effectively expanding and integrating Conveyor with to provide some other workflow opportunities. Rhino.Inside.Revit out of the box is very Grasshopper focused, kind of provides an alternative computational design framework for Revit in a way. If you're a Grasshopper user, Conveyor exploits a similar pathway, but kind of creates a very simple user interface for clicking Rhino objects. So if you're more in the direct Rhino modeling space, we're building on top of this. So let's get into some of the fun stuff. So what I am going to do is step through some examples. I'm going to be using this beautiful tower as a kind of a demonstrator. Just disclaimer, I don't consider this high quality architecture by any means, but what I did was, when I composed this model as a test model, I wanted to capture a couple of key geometry types that we can use to demonstrate some of the functionality. So we can see as we've got a kind of a complex skin. The skin is a sub-D object that has been created inside of the Rhino environment. Subdivision modeling is one of the new Rhino 7 features, so I thought it'd be cool to kind of show what that can do. You can kind of see it's generating a single surface subdivision object with these kind of holes punched out of them and some kind of complexity in how these penetrations kind of protrude from there. We also have some complex polysurfaces that have different trimming information joined together, multiple faces. We have a mesh object representing a landscape. We have floor plates that are being sliced, levels, and so on. So this kind of provides maybe perhaps a variety of different element types that I can kind of walk you through. And the objective of this workshop will be just to take this model as it's currently structured and bring the various objects into the Revit environment, and also use some Revit information and bring it into the Rhino environment as well. So when you install Conveyor, there are a couple of plugins that are installed with it. If you download the trial, for example, you'll get a Conveyor command that will activate in Rhino. And what this is going to do is it's going to create some model organizers. There is a kind of layer structure that's created. And there's also this interface that is created as well. And what this interface allows one to do is that even though I'm not in Revit at the moment or interacting with it, this interface allows me to start to assign some meaning to these objects. One of the challenges from when you're working from Rhino into Revit is how do you provide some level of understanding of what a surface in Rhino actually wants to be when it's in Revit? How does Revit know that this wants to be a floor? And what we're able to do with this Conveyor interface is, basically allow the user a way to assign some of that information. So what I'm going to do is first I'm going to demonstrate some of the importing workflows that we have here. And so when I kind of go in to this model, this is just this model was created independently of Conveyor. So you can see we have these like layer structures and objects on some layers. Your firm may have different ways with which you organize Rhino objects and so on. What I'm going to do is maybe start with something really simple here, and I'm going to select these text objects. These text objects are indicating some level datums in space. And I'm going to select these objects here. And the elevation of the text and the name of the text object in Rhino is really going to be a driver for things like levels in the Revit environment. So what I'm going to do here is you can see under Conveyor, I'm going to say, hey, I want these objects to be levels. And after I do so, I can simply save this file. And these are now going to be kind of understood by Conveyor as something that needs to control the level creation. So I'm going to just jump over into Revit now. And so in Revit, when you install Conveyor, there is going to be a Proving Ground tab. And if you're looking to import an external file, you can use what we're referring to as the Rhino Conveyor add-in. And what this will do is it'll open up the dockable interface that can act as a bit of a workflow co-pilot for you if you're working in Revit and you're looking to migrate objects in from an external file. I can click on the set file location, and I'm going to find this workflow here, workshop tower start. Now, this is the file I was just working in, and I'm going to click open. And what this is going to do is it's going to open up a file, and it's going to provide me with an itemized list of objects that are kind of assigned to a Conveyor category. So before I was over in Rhino and I said, okay, I want these objects to be levels. So now we're getting an itemized list of objects in this Conveyor interface that say, okay, we're going to create levels from these objects. So I'm just go ahead and load these objects in. I can choose to obviously select just one or a few of these objects. But here I'm just sort of selecting all of them. So I'm just going to go ahead and yes. And what this is going to do is it's going to import those objects and generate native Revit levels that are being derived from the Rhino information. And we now have a set of level datums that are mirroring the Revit information, right? I can also do the same type of thing for kind of a floor-based import. So here we have, I did levels, so now maybe I want to have my floors hosted on those levels. So I'm simply going to find my floor surfaces, and I'm going to assign these to a floor category. And then you can see I have a number of different types that are generated by default here, which will allow me to assign 12-inch floors, 12-inch thick generic floor here in this case. And I'm just go ahead and hit save. And I'm going to jump back over into Revit, and I'm going to do a little bit of a refresh here on the object, on the conveyor dockable window. And you can see that what Conveyor has done is it's detected that, hey, you have levels that were imported before. Conveyor has identified that those objects are up to date with the Rhino model. So those become unselected. And then I have some new floor objects that have been classified. So now I have these floor objects that I can choose to import in, right? So I'm going to go ahead and hit load Rhino objects here, and 36 elements are going to be loaded in. And it's now going to go through this process of bringing in those floors. And you'll notice that it's taking the information from Rhino and it is constructing, in this case, native floor elements here. So what I can kind of see happening here is if I come over here into the floor category and I say, all right, well, I'm going to double click on it. I can certainly choose to edit this boundary if I wanted to. I can change the floor type if I wanted to. And I can also schedule these objects and get kind of area takeoffs from them. So it's as if the user had drawn these manually. We're using the kind of API automation to do this. And what also becomes interesting at this moment is that if I have a change to my Rhino file, let's say I'm kind of over in Rhino now and I maybe want to edit this top floor, maybe I'll just go ahead and isolate this top floor here, and I say, well, maybe I want this this object here to have a bit of a wider opening, for example. So I'm just go ahead and move this edge and pull it out. Of course, I have project on, which is giving me a little bit of trouble. That's fine. So I've edited this floor shape, and I'm just go ahead and hit save on this file. And I'm just going to jump over into Rhino now, and I'm going to do a refresh on this model. And what we're going to see is that those levels are up to date. We have a number of floors that are up to date, but hey, there's one floor that is now needing an update. So it's actually been able to compare the state of the Rhino model with the state of the Revit file and identify that there is in fact one floor that needs updating, and maybe I'll even filter this list. And so now there's that. So I'm going to go ahead and load that object in that needs updating and pull that in, and it will create that update to the floor. So this is sort of kind of very much based around that paradigm again of importing external files, external geometry into the Revit environment. This is supported in Rhino 6. This type of workflow can involve disconnected Rhino and Revit models. But it is also very kind of, I would say, one directional. There's really not a pathway here for, say, taking a Revit object and putting, kind of exporting it into Rhino more directly. There's also, if you're not working with a, if you're working on your own, it could also be maybe a little cumbersome to jump back and forth. This workflow is really in some ways designed around the paradigm of, hey, you might need to just grab, someone might have sent you a Rhino file and you're trying to bring in different objects, or a colleague of yours is working on the Rhino object and you're just kind of trying to manage the development of the Revit file. And so they're kind of happening as parallel operations. Still a great deal of efficiency gain here. But you might want to have something that's a little bit more directed, more direct, and more of an integration scenario. So this is where the Rhino 7 toolkit can really lend some, I think, additional value on top of this process. So what I'm going to do here is I'm going to go ahead and close out of Conveyor. And I just have now my Revit file up and running. And what I want to do instead here is start to use Conveyor's logic and some of the translation workflows that we have here through the Rhino inside paradigm. And so as I mentioned, we are really extending this capability now with building on top of this type of kind of Rhino Inside plugin. So if you have the Rhino Inside plugin installed, what you are able to do is start to use that and start to access different conveyor functionality. So what I'm going to do here is also close out of Rhino. That is, this exists outside of Revit. So I'm going to go ahead and make sure I've got this all saved. Jump out of it. And with Rhino Inside installed, you see that we have an add-ins tab here, and I'm going to go ahead and activate Rhino Inside. And of course, it's going to tell me that the work in progress for Rhino Inside is going to expire in a couple of days. Do you want to check for updates? I make it a policy never to update my programs on the day of a workshop because I have experienced my own great deal of pain and suffering when I've done that, and find that something kind of becomes a little offset. So I'm not going to do that this time around. But what it's doing right now is it's activating the Rhino Inside plugin. So while it's doing this, I'm going to just go take a look at the question. I do see a question in the Q&A here. Will this work with metric units or just imperial? The answer is that it does work with both units in the workflow. So if you have, like, say, a metric Rhino file, it will do the unit translation and bring things over from an import standpoint as the proper size. Even if you're working in an imperial file in Revit, it'll handle that.
Hey, Nate, we've got a couple of questions related to the floor and levels thing. Do you want to address those here quick, or do you want to wait until the end?
Sure. Are those coming through in the chat or the Q&A?
Yeah, the chat. So
okay, go ahead.
Let's see here. First is the data generated by conveyor actions, like indicating something as a floor, stored in the 3DM, or are they lost when conveyor is closed?
So it is stored in the 3DM in the form of classifications. So when I classify a surface as a floor, that object is classified as a floor, and if I close the Rhino file and then import that in, then yes, it will kind of maintain that persistence. I don't even have to have Rhino open to run the workflows I was just showing. It's the process is that you're basically assigning some level of meaning to your object and you're classifying it. Then Conveyor, the Revit add-in, will interpret that classification and perform the automation of basically drawing the floor objects.
There's a question about the floor element in Rhino creating a level in floor in Revit. What defined the Rhino text as a level?
So that was also, in fact, why don't I go back to that here? It's a good question. So if I go to Rhino 7, so these classifications are basically driven by the conveyor interface here. So if I click on this object for the text, I have actually told it to be a level object. And therefore Revit and the kind of import process will say, okay, process this location of text that has this name and derive the level. And the same thing is true of floors. If I click on this floor, you can see that the category is a floor, and I've told it what type of floor I want it to be. So this is like basically the conveyor tool allows one to assign these types of classifications to objects, and then the add-in will process them accordingly.
And then one last question. In terms of when you input a floor into Revit, you can still change the properties of that floor once in Revit, right? That's right. That's native. That's a native geometry of floor.
That's right. So this particular floor that's been generated is a floor, and if I wanted to change it to a different type, say lightweight concrete on metal deck, it will adapt to that new classification afterwards. Yeah. So a major premise of both the import workflow and the workflow I'm about to show is that when the objects end up in Revit, they are Revit objects, like that's generated through automation, our kind of own novel kind of processing of geometry. And then the Revit file can stand on its own, and other people can start to ideally work with it, slice it, document it, and so on.
Great. So the other questions I think you'll address in your Conveyor V2 dialogue, so I'd say keep going.
Okay, yeah. And there will be a couple of moments here where a couple of elements will take longer to process, which actually make for good Q&A breaks as well, because we're going to have, I think, a facade here that's going to have a ton of different objects being populated. So, so kind of just to back up for a second and recap, I've activated Rhino Inside now. I'm going to close down Rhino External just to make sure I'm not doing anything that is going to conflict or show me that it's open elsewhere. So I've activated that. And when you have the Rhino Inside tool active, it creates a Rhinoceros tab, drops you here. So then this then enters you into the world of being able to open Rhino inside of Revit, hence the term Rhino Inside. There is a Grasshopper tool. Most people that are using, I would say, the Rhino Inside are kind of really leveraging Grasshopper. So Grasshopper being the parametric modeling environment for, with computational design capabilities. In some ways can act as a bit of an alternative to Dynamo because you can perform similar operations. We became interested with Conveyor is just being able to have Rhino as a modeling environment. So we wanted to really activate and position Conveyor as a way to, if you're into direct modeling and you are interested in deriving surfaces and using all of the commands that are available in this freeform modeling editor, Conveyor can become that kind of conduit for kind of direct passing of objects into the Revit environment, and without the need to kind of get into kind of Grasshopper or computational design workflows if you don't have that skill set, or our objective really is to democratize this kind of level of compatibility. So what I've done here is I've activated Rhino 7 through Rhino Inside. So now I have a Rhino interface here. You can see that I have the Conveyor plugin active. This is the same plugin that was shown in the previous exercise where I kind of assigned some object types. What I'm going to do is I'm going to go ahead and open up that model that I was working with before. I'm going to go ahead and open up Start. And so now I'm now working with that model that I had started to work with over here. These objects were imported before, and maybe just to kind of do a little bit of screen management, I'm gonna kind of push these off to the side so they're parallel with each other. So I have kind of some mirroring. So now Rhino over here, Revit over here. And what I want to do is now start to use the kind of direct translation method to start migrating objects over. The first thing I'm going to do is kind of also show that, hey, this floor, remember this floor that I imported in before, because this is the same model, it will have an impact on, this floor here. So if I wanted to do something like, I'm going to move this edge back to the core, like so. On your snaps, so I've updated that object. You can see that it's still classified as a floor. There is, when activated through Rhino Inside, I have this expander called Rhino-Revit Direct, and I'm going to go ahead and expand that down. And when I'm running Rhino in this way, I can just simply say, okay, we'll send this object over into Revit. And what this is going to do is it's going to reach over into the Revit environment. And it's going to update my floor. So now I've basically pushed that change back into the Revit environment, and that floor that I had there existing previously is now updated and changed. And so this principle starts to apply across to a variety of different object types, which I'd like to kind of explore with the group here. Let's look at structure. So I've got a bunch of floor slabs in here. If I look at my conveyor model, or my Rhino model here, I can start to do some things with sort of some of these structural elements. And so I've got a layer set here. You can see that I have just a general collection of objects under structure. I'm going to go ahead and select these objects here. And I'm going to go and isolate them in Rhino just so I can have those on screen as such. So a variety of different toolkits, a variety of different object types. You can see I'm starting to lose real estate because I'm running all of these applications in kind of one screen. Normally I'm working in parallel screen mode, so that's kind of maybe a workflow productivity tip. You can kind of see I've got a number of objects here. What I'm going to do is I'm going to translate these as elements over into the Revit environment as well. At the moment, they are unassigned. I'm going to go to components, and I'm just going to say, let's make these columns just as a basis of working, and I'm going to go ahead and pass these over. One of the things that you'll note here as an option, since I'm working with solid objects, I have two opportunities to translate objects over. One is to create these as families that will be kind of component families that are loaded into the model. This tends to be more reliable than direct shapes, but it's also slower. Since I'm working with some pretty straightforward geometry here, I'm going to actually opt to do these as direct shapes. So I'm going to go ahead and just uncheck family creation and send these over to Revit, kind of see what the result is. And then we can kind of inspect them a little bit. So what it's doing is it's jumping through and it's creating a number of different objects. We try to provide status bars where applicable to kind of let you know the status of this thing, and it's going to go through a set of now Revit transactions where we are injecting these objects as column classified shape objects that are kind of populating the model. And when this is complete, we'll kind of see kind of then some further build out of our model here. So we now have floors, levels, and these objects. If I kind of zoom in on this object here, you can see that it's a column classified object. So if you have visibility graphic settings and things like that that are important to you, those will pop up as well in your various views. Go ahead and unhide the rest of my model here in Rhino. Another kind of element type that I think is kind of novel to be aware of are things like maybe these landscape meshes at the base here. So you can kind of see that I've got deliberately a set of mesh objects. And normally when you think about Revit and you think about meshes, those two things don't really play well with each other, right? Because if you bring in, say, a mesh DXF file or a mesh DWG, you end up with a mess of mesh wires and things of that nature that are being brought in. Conveyor introduces some pretty novel mesh-based processing that will allow a mesh like this in Rhino to really come into the Revit environment and be a cleanly represented mesh that doesn't have sort of wires displayed unless it kind of passes an edge threshold. So what I'm going to do is I'm just going to show this processing. I'm going to assign it as a mesh. And in this case, I want to make it a site category object. In this case, I am going to create it as a family. And what this is going to do is it's going to place a site categorized family with some post-processed mesh operations applied to it. So I'm going to go ahead and hit send this over to Revit. And it's going to go through the kind of conveyors processing and generate the mesh object. And there it is. So this is indeed a mesh. You can kind of see some of the silhouetting of this. You'll notice that the edges of that mesh are hidden on some of these kind of creased areas. You're starting to see some edge articulation. If I go into shaded mode, you'll see that there is mesh tessellation in play. So it's, this in this case isn't a very high resolution mesh, so that's kind of very apparent in the sort of shaded view. But this kind of workflow does allow one to work, I think, more directly with meshes. If you have meshed objects from other programs, whether it's a landscape, we've done some really complex facades that were developed in like kind of Maya and other software where mesh processing was kind of instrumental and key. So I think that's, this opens up some usefulness to that type of geometry, which is I would say in the past largely ignored or discarded just because Revit and mesh imports aren't necessarily useful, other than maybe some rough coordination activity. So I'm going to pause here and maybe take a look at some of the questions.
Yeah, I've got one that combines two questions here, Nate. It talks about the relationship between elements between Revit and Rhino.
Mm-hmm.
For example, you'd already had that last floor created in the previous Rhino file, which you then opened up inside using Rhino-Inside.
Yep.
Have you managed the link between that Revit floor and a new Rhino file so there's no geometry overlap? Or do you really need to just keep using the same Rhino file?
Yeah, that's a great question. You do not need to keep using the same Rhino file. Conveyor does recognize where objects are essentially coming from. So I could have one Rhino file that is being imported using the, say, the Proving Ground conveyor workflow here, where I'm activating the sidebar. I could be bringing in objects through this interface and have a completely separate Rhino model open over here that brings objects in through that pathway. So you're really able to mix and match these types of operations. I could also even start a workflow with the Rhino, like say I started this model over here. If I wanted to then switch this up to where I'm importing objects through another file, I can certainly do that. So it's kind of modular in that way. It's not designed to like lock you into one model or one approach. It's really meant to kind of allow you to kind of interface and play air traffic control between the various data sources that you're working with in terms of importing and exchanging information with Revit.
Another question kind of related to what happens when you're in Revit and how do you take that back into Rhino? So if you change the opening on that top level floor in Revit, can you get that to show up in Rhino? Or even if you delete a floor in Revit, does that take away a floor in Rhino?
So I'll be talking a bit about the other direction here in the second. So you can kind of see that we have a Get from Revit button as well. The answer to that is, there is a degree of mirroring that happens between like kind of these environments, but there are some things that like, if I were to delete a floor here, I may not want that to impact my Rhino model, or I might want to make sure that I'm doing some deliberate things here. So there are ways to kind of, I think with any given workflow, while you can introduce tight integration, you also want to have, I think at a certain point, disintegration as well. Because ultimately, in a lot of cases, you want to have the Revit file as your deliverable, and you may not want to send an adjacent Rhino file over with it. So we're kind of trying to walk a very careful line on, how does where do the integrations occur and where do they kind of separate? It's kind of important to know. So I'll be kind of covering a couple of those scenarios here and in some future steps.
Yeah, I think the other questions you'll get to address here, so I keep going. Okay,
great. So I'm going to just go ahead and kind of clear this out, give myself a little more real estate there by closing the Rhino layer. Let's talk a little bit about some of these other objects that I have in here. I have this roof here, which has a number of different elements. You can see I have some trimmed surface geometry. I have these skylights. These do have some materials to them. So if I go to rendered mode, you can see that there's some transparency that's assigned to this. This actually has a glass material in the Rhino environment. And the workflow I wanted to kind of articulate here is the idea of using blocks and how blocks can be used to generate native Revit families, and how certain data points about that block, including some of the underlying material systems, will also translate over and be kind of exposed in Revit. So what I'm going to do here is you can see I've got a number of different objects inside of this file representing this complex roof. I'm going to go ahead and click on these objects here. And I want to basically say, you know what, I want this complex roof system to be kind of a complete assembly. So I'm going to turn this into a block. And what that means is that these objects will be grouped together and basically serve as and we'll have sort of subcomponents. So if I click into the block, I can edit it and just sort of treat it as an object. So I'm going to call this the roof block object and hit OK. So now I have this block classified as well. It is currently an unassigned block that has sublayers. If I open up my layers again here, you'll see that we have kind of a steel layer, and we also have this that's the facade, I guess. What I've done here, let's see, we're podium roof. Yeah, so I've got like this skylight and I've got this podium roof layer that are really making up that block. What I want to do is I'm going to classify this as a component family. And I'm going to give this a generic model category. And because it's a block with multiple objects, I'm going to use Conveyor to translate that as a native Revit family into Revit. So when I click hit send to Revit, what it's going to do is it's going to find that, hey, there's a block definition here that you've selected called roof block. Would you like to load this in as a family first and then place it? And here I'm going to go ahead and hit load. And it's going to basically translate that geometry and generate a family. And so behind the scenes, it's kind of preparing a family file. It is going to be importing in the different components of that family. And then it'll load that family in the model and ultimately place the family object. This tends to be one of the sort of more slower operations because it's kind of going through a number of different steps, but it can also turn out to be, as you'll see, I think a pretty powerful workflow opportunity, especially if you're dealing with collections of objects that you're looking to develop more manually. And I'll also be touching on this block workflow when it comes to the facade system as well. So here you can see it's bringing those blocks in, loading it in, and there we have a, looks like it's regenerating the model, classic Revit regeneration process. And placing. And there it is. So what that has done is this is a family. It's a generic model family, roof block. You can see that it has this transparency to it. So if I go to my shaded mode, what you're going to see is that it has translated the materials for those objects. If I double click into this family, it will give me access to some of the individual objects that have been brought in. But it's also, if I click on this, you'll see that it's a what's called a freeform element. So it's not a direct shape. Freeform elements have the ability to receive and have editable materials and allow for subcategory classification and so on. So it's very flexible versus sort of a, I guess, a direct shape, which would bring it in as a single block, and they're not very editable after the fact. And also they're not nearly as forgiving as objects. But in this case, we have a family object. You can see that we have a set of materials exposed. You can see the glass material was found as well. There's one material here for the roof that was not assigned. So if I go in here and say, you know what, maybe I want this these surfaces to inherit a different material, say a kind of maybe an aluminum. There's like a, I don't know, aluminum panel roof. I don't have a grass texture loaded. Otherwise I would use grass. It's now going to kind of assign aluminum to that material there on the roof. So we now have kind of a nice block, family representation of that kind of more complex element sitting in there. Following along those same lines, we have blocks that are kind of representing this facade here. And there are, I don't remember how many facade elements there are, but there's quite a number, I would say, of them here. And one of the things that makes this block workflow so powerful is that I can start to really leverage this idea of type and instance within the Revit environment. So if I have a block, it's going to create one family for this one block, and then it's going to position that family around the model along these different positions. So maybe what I'm going to do here is I'm going to just kind of collect a handful of these pieces just to, I don't know if we have time to do all of them because it does, has to process a couple of hundred elements. And I want to make sure I get to kind of all these element types I want to do. So I'm just going to go ahead and select these objects here. These are unitized curtain wall blocks. I'm going to just kind of bring these in as component families. And what this is going to do, it's going to do a similar type of workflow where it's going to translate the block and then it's going to position the block. So I'm going to zoom in on the area of the model where it's going to pull these objects into. I'll go ahead and hit send to Revit. And it's going to give me another message that will say, do you want to import the block object? There's a standard unitized block. I'm going to go ahead and load that in. And it's going to create these files. So while this is happening, why don't we go ahead and look at, is there a queue of questions coming in, Steve?
Sure. So how would Conveyor work with meshes from analysis done in Rhino like Ladybug and Honeybee?
So if it's a mesh, it will come in. I'm assuming since it's the question is around Ladybug and Honeybee, the question is perhaps around the color of the mesh as well, like the gradient analysis.
Might be. I'm not. Alexander asked this question. If you could add more detail in the chat, we can probably address that specifically.
Yeah, I would say there is a feature here that might be of interest in that case. To be honest, it doesn't involve translating the mesh over as an object, but we do have some preview capabilities that will allow for a multicolored mesh to appear in the Revit environment from Rhino. You'll see that we have a couple of preview features here, preview and clear preview. This would allow one to preview a mesh and through this preview process would also display mesh colors. Unfortunately, I don't have an example spun up right at the moment that would allow me to do that, but that might be a good point of follow-up. Maybe I can do a follow-on tutorial on that question.
Yep. Yeah, and Alexander specified that they were talking about the colors.
Yeah, nice. So here is, you can see that we've loaded in a family object here. You can see that we have if I hover over, kind of basically a translation of that block object, and then many instances of that block object being populated here. What kind of makes this workflow cool is that since I've now brought these in and have pushed them into Revit, if I go in and let's say now I'm like, okay, well, I'm just going to start working with my Revit model. And maybe I want to do some post editing to these families after they've been brought in. Maybe I need to add more detail, or I want to edit something about them. I'm going to go ahead and just maybe do some alterations to these objects here. You can see that because we're bringing them in as freeform elements, there is some level, especially with extrusions in particular, I can start to control these objects and delete some things out, maybe change some materials inside of them. So you can see I edited the kind of dimensions of these extrusions here. I pulled out that object. I'm going to go ahead and load this back into the project and close it. Actually, cancel. I'm going to just go ahead and load that in. So it's going to overwrite the existing version. And so in no Revit, I don't want to save my file. So there we have it. We have a, since I made some alterations to the family, that kind of family is now kind of changed here. You also notice that this family inherited the glass material as well as this steel ASTM material. And the way that it's able to do that is that Revit happens to have some materials that are match the names of some Rhino materials. And so it's able to kind of pull those things over and interpret those as, needing to be assigned there. We have some, some documentation on that on our site as well. Other things, I thought it might be interesting to show, maybe what I'll do here, and maybe this will maybe help pause for some questions as well, because this will take a minute or two. I do have this sub-D mesh in the model. You can see that there is quite a bit of complexity to this. It's just punched openings, but for those of you who aren't familiar, like sub-D meshes are Rhino's answer to subdivision modeling that occurs in other software. So I can manipulate the different this cage that will allow me to edit these things in a pretty fluid manner. I can add polygons. I can make stuff that would be very difficult, if not impossible, to do using normal NURBS-based modeling. It really does open up a lot of sculpting opportunity with Rhino that we're me personally, I'm really excited about. I miss those types of tools from like working in Maya and Studio Max back in the day. So it's cool to have them here. Also, shout out to my colleagues that used to love T-splines. I used to use T-splines all the time inside of Rhino. So this really makes, really adds that functionality back in, and it's now baked into the core of Rhino, which is awesome. But what I thought might be cool is to just maybe do a quick send of this object into Revit as well, and I'll classify that object. So these come across as meshes. It uses sort of the underlying cage and derives a mesh object. This will, okay, so the name, I did see this come across the chat. What's the name of the substitute for T-splines? It's in Rhino 7, and it's called Sub-D object. So Sub-D objects allow for that similar type of manipulation. There are some things that aren't quite there that T-splines had, but it's pretty dang close. And there are a number of different strengths that the sub-D objects have over T-splines that I think make it quite appealing.
While this is loading, Nate, I think it's a great time to answer one question about what geometry can be classified as different types of Revit categories or types. Yes. So one actually common question we've had today was, when you were demonstrating the floors, there was a thickness to the floor in Rhino, but that didn't necessarily translate to the thickness of the floor in Revit because we specified a specific type that existed in Revit by typing that name in, right? But there's probably other limitations on types of geometry that can be assigned to floor or others, right?
That's right. And this is where we've invested quite a bit of time into creating some documentation at an element level to really help our users understand the behavior of different objects and how different things can come across. So the first thing, so I'm sharing the documentation right now. If I go into, for example, the compatibility summary, the compatibility summary page basically goes through and itemizes the element types that are supported, from adaptive components all the way down to floors. If I go into floors, for example, there are a number of options for how floors come across. So for example, the workflow I showed was this idea of a planar surface workflow. And what we're doing is basically saying that a planar surface as a geometry type in Rhino can hold the boundary conditions of the exterior of a floor as well as the interior boundaries. Basically, we're using Rhino's sort of BREP structure to sort of identify, okay, what are the edge conditions of the floor, both internally and externally. And then by kind of assigning these to a floor type, Revit will then interpret that trim surface and produce a floor. There's other workflows. So for example, if you were given a complex floor and those complex floors were solid, here you can see we have a non-planar floor element that is extruded as a solid, and I'm giving them a floor category. What Conveyor will do is it'll say, okay, you have a solid floor. It's irregular. It's not a prop. It's not like something that you would necessarily draw with a type to it. What this is going to do is it's going to take those geometries, classify it as a floor, and generate a direct shape object for it. So it's a floor classified direct shape in this case. So there's a couple of options for the user to choose from. And one of the things that what we're doing with Conveyor in particular is we do provide some hints for how this works. So if I go back into Revit here, you can see, yep, there's my mesh object, sub-D mesh object that's been brought in. If I click on, say, this object here, this surface, and I look at the categories, this category list becomes filtered down to things that a user may want to classify the surface as. I'm saying it's a floor, but maybe I do want to bring this in and classify it as a structure. So it'll basically become a surface element that has a structure classification, face-based wall, things like that. Versus if I click on this solid object extrusion, I have a number of different categories. So this solid may want to be a component file, and there's some tooltips here that kind of provide some explanation on what it's expecting to do, how different things are going to be classified. But yeah, so there is a bit of kind of knowledge that needs to that you'd have to learn along the way, but hopefully a combination of our documentation, which you can access through these interfaces as well. So if you need help, it'll take you through that to the documentation, and along with some video tutorials on how those work. I know we're right at the hour. Is there any kind of final questions here?
Nothing too new. One thing was a question of Rhino Inside and how Conveyor is kind of leveraging that. Question was, so we can't use Rhino Inside without Conveyor. I think the point I made is we're leveraging Rhino Inside here to get these tools into Revit itself. But Nate, if you want to expand on what Rhino Inside does for us.
Sure. Yeah. Well, so as I mentioned back to, maybe this is a good chance to maybe just do a quick recap on this. So if I go back to this diagram, Conveyor operates in two modes as a summary. There's a mode that allows, that basically says Rhino and Revit are independent programs, and I can work in Rhino and import objects into Revit as I need through the kind of import interface that we provide. But we also are able to create a level of integration with Revit directly using the Rhino Inside paradigm. What that basically means is that when you activate Rhino through the Rhino Inside program, our plugins and tools are compatible with that paradigm. So you're still using Conveyor's logic. You're still using the ability to kind of post-process meshes and generate these objects, use the Rhino interface directly within this paradigm. But because we're connecting through and stacking on top of Rhino Inside, we're able to get this kind of direction happening. So it basically, I guess in a sense, we've created and established if it's plugins within plugins at this point. You can have Rhino as a plugin to Revit and Conveyor as a plugin for Rhino. You're able to kind of interact with, back up through that stack to Revit and so on. So we're kind of expanding the Rhino Inside paradigm with Conveyor. But Conveyor can also be used independently of Rhino Inside through the import workflow. So you can kind of mix and match. You could also theoretically, expand on Conveyor nodes within Grasshopper, and I was hoping to kind of demonstrate that here until we had a bit of a snafu there at the end, but to show that, yeah, you can connect the Conveyor components to Rhino Inside components and have those work together as well.
When will V2 be ready?
You can go to the website right now and get a trial. So if you go, it's currently the only version available. We can, if you go to Conveyor, try and buy, there is a 15-day trial that you can download and give a shot out to, and give it a shot, see if you like it. As I noted, that Conveyor supports, if you're using Rhino 6, you can still use all of the Rhino, the Conveyor import capabilities where you have a Rhino file and you're importing things in. If you are wanting to use the Rhino Inside feature set, you have to have Rhino 7. So really this workflow here includes all the same, all the functionality that was in V1, but layers in the Rhino Inside compatibility and expands the Rhino 7 support. So we're kind of growing with the technology that's out there, but we're also ensuring that the previous workflows that people may be using in V1 are still relevant as well. There was a question. Oh, go ahead.
Oh, go ahead. Well, I was just going to say we had a question about student discounts and the cost of the tools for students and educators.
Great question. So we do have an educational suite licensing approach. So currently we're going to be rolling out an update to this in the next week or so. The current educational package is for V1, the first version of Tracer and Semantic, and those are kind of bundled together as a $77 purchase. If you do this bundle, we will provide free upgrades to students to the sort of version 2 that's now available, and as well as any update to the other things. So if you're a student, we're really hoping to support the student and educational community with these tools. We've had some really great adoption. A couple of universities have had us set up university bookstore setup, so you can, if there are folks on this call that are interested in that kind of way of providing students access to these tools, we're more than happy to work with you. Otherwise, send us an educational request and we'll get you set up. Is that it?
I saw some interest about the components in Grasshopper, but it sounds like we can touch on that in the future.
Yeah, we'll definitely have a follow-up workshop and tutorial on there. It seemed to be that with every workshop there's something. I would have liked to have shown the adaptive component piece, but take a look at our YouTube when we have that tutorial ready.
There was a question about the price to upgrade from V1 to V2 for commercial and as well as education.
Sure. So the price to upgrade for education, students will get free upgrades. There is a V1 to V2 discount that we provide. So if you have V1 right now, you can reach out to me directly or through the website at contact and request an upgrade discount. What it basically amounts to is that if you're a V1 user and you've adopted that in the last year, you can get an upgrade for $100 US, and you'll have the upgrade. So we've tried to make that. And actually, if you ended up, I think the approach that we've taken is if you downloaded the V1 standard and you're doing an upgrade to V2, you're actually getting V2 at a lower price point than if you were to just buy V2 directly. So we are trying to say thank you to our current users and the folks that are supporting Conveyor with those purchases. And so, yeah, happy to have a chat if you have questions about that process.
There's a question that we didn't touch on when we were going through the geometry date about the coordinate system between Rhino and Revit.
Oh yeah, so that's a good question. The way that it works is that Conveyor's translation logic will detect what Rhino's units are and will make the requisite conversions as needed to the Revit environment. So even if you had a metric Rhino file and you're bringing it into a feet and inches Revit file, it would handle that translation as well. and use that basis. So we haven't seen, or at least we haven't had reported issues on that when it comes to the translation. But yeah, we're keenly aware that people work in different units. I see a question coming in as floating licenses. Presently, we do not have a floating license set up. That's something that we're going to be working towards this in the next year. So everything is perpetual. That's another thing that's kind of important to note, is that we are offering perpetual licenses. These are not subscription tools, so there's no recurring fee. When you can get them, they're yours. You do have the ability to transfer licenses to different devices. A single license can be installed on up to 2 devices at a time. We do work with organizations that may have a larger pool of Rhino users to create kind of an enterprise license that is economical to your user pool. So you're able to kind of share among a larger group of users. So it's not floating if you have that need necessarily, but it can, for larger teams, be far more convenient to work with us on getting set up with that.
Looks like we got a compliment from an educator who's using these tools with their students. So I'm happy to see that the adoption there is successful in their studio process.
Great. Awesome. I'm glad to hear it. I wish I had these tools when I was a student.
Get them while you're young.
Yeah. Great. Well, thank you so much, everyone. I hope this was informative, at least seeing the tool live in action, seeing some of the steps that I was going through. We do have some sample files of everything I showed here, so I'll probably be following up with the folks that signed up for this webinar, so you can access these files if you haven't downloaded them already. There is a link included in the invite that had some of this information. But thank you so much. I'll let you all know when this is available on YouTube.